All right, so you are now starting your next unit, Unit 2. It's all about matter and chemistry. This is our chemistry unit. So in this video clip, and for your first set of checkpoints, there are 3 checkpoints you're going to get through with this video. We are going to be talking about what is matter. We're also going to talk about the states of matter and a little bit of phase changes going from one state to another. Obviously, I have to start you off with some jokes. So you got Einstein, hopefully you recognize them, and it says, you are living, you occupy space, you have a mass, you matter. You'll see in a minute that matter is anything that takes up space and has a mass, so you're all matter. And the other one is you matter until you multiply yourself times the speed of light squared. Then you energy. If you know Einstein, E equals mc squared, energy equals matter times the speed of light squared. So that's where that joke comes in. And I bet all of you are looking at me like this. Nobody laughed at my jokes. But that's okay. I'm not going to stop telling them anyway. So, what is matter? Feel free to pause this anytime you have to in order to write stuff down. But matter is anything that takes up mass and volume, or that has mass and volume. So anything that takes up space. Okay, so like this pen. I can see it, it takes up space. The water in my water bottle. It's taking up space inside that water bottle. The water itself. This is a weird one. Air. This water bottle is not half empty. In fact, it's totally full, but only this much of it is water. This part of it is air. Air is taking up space. So an example of matter is air. At this point, you should pause this video, pause it, and on your fact sheet, it says, and I'm backwards here, but that's fine, to turn and talk. You and your neighbors around you should be right around the same place. So pause this video, and I want you filling in those boxes. I want at least 10 examples of matter. Don't use the ones I gave you. And at least 3 examples of things that are not matter. That one's hard. Something that does not take up space, doesn't weigh anything. Perhaps it's not something at all. That's a hard one. So pause the video. Call me over if you need help, especially with that non-matter one. And you cannot move on to the next part, can't hit play, until you get initials right there showing that you got all your examples of matter and non-matter done. So pause me. Okay, welcome back. Hopefully you have had your teacher, me, or another adult in the room sign off that you have all of your examples of matter and non-matter, and we're all on the same page here. So next, we're going to look at different types of matter, states of matter, the forms that matter can come in. Are you sick of hearing me say matter yet? That's too bad. So your states of matter, we have solid, liquid, and gas. Those are going to be the 3 main phases. There's actually 7 that scientists have discovered, but most of them are not found on planet Earth. Google it if you want to, okay? But we're focusing on these 3, solid, liquid, gas. I got a little cartoon of my dinosaur there, solid, then they liquefied, and now they're gas. Get it? They're gasoline, fossil fuels. You'll get it later. Don't worry. All right. So the first state of matter is a solid. And the thing with a solid is, and pause this at any point, its shape is fixed. Okay. If I have this deck of cards, its shape is fixed. It's not going to go shape shifting. It's not going to turn into a bubble all of a sudden or morph into a circle, or this is its shape. It's not changing. Its volume is fixed, meaning its size is also not going to change. I'm not going to leave it on my desk and all of a sudden come back and it's 10 times bigger or itty bitty. This is its size. This is its volume. All of the molecules that make up this deck of cards, they're packed really close together. That's why I can't put my hand through it. They're packed too close together. Believe it or not, all of the molecules that make up that deck of cards are actually sitting there shaking. They're vibrating. They're so tiny that you can't feel them, but molecules never stop moving. So these molecules in a solid are vibrating really slowly. They're packed really close together, and they're not going to change their shape or size. Now, in this box right here, we need to draw what that looks like. Okay, now, again, my drawing skills are not that great, but we're going to try. So there's an atom, there's an atom, there's an atom. They're really close together. Whoop. Oh boy. We're going to pause this video and we are going to start this part. Okay, so we are going to try to draw our solid. And we're going to draw all of our molecules. Now, again, I'm not the best at using this mouse. So each of these circles is an atom. They're packed really close together. Your circles can touch. I'm not very good at this. All right, which means mine, I'm going to kind of make it smaller than what yours will be. You can fill up this whole box. All right, there's my solid. And then I'm going to try to draw for you, showing that it's vibrating a little bit. Those are like the same symbols they use for cell phone vibrations. Hopefully your version of this is better than mine. Call me over if you want me to draw it for you in real life, because I know that's not that great. Okay, so there's our solid. Now we're just going to erase that, and we are going to move on to liquid. Okay, so now we've got liquid. Now this is obviously like liquid water. And the thing about liquid is that there is no fixed shape. It takes the shape of whatever container it's in. So right now my water is this shape. If I tip my water bottle, it has now changed shape. If I pour it out onto the desk, it'll take the shape of the desk. It'll spread out and be nice and flat. If I pour it into a water balloon, it'll be the shape of a water balloon. So it has no fixed shape. However, the volume is fixed. This amount of water, the volume in here, is the same amount of water, is the same amount of water as when I tip it like this. The volume has not changed. If I pour it out onto the desk, it's the same amount of water. It's just now on the desk and not in the bottle. Okay, so the volume is fixed. However, the shape can change. Now, these molecules, they like each other. They're mostly touching. You can easily put your hand through a liquid, though, so they're not as close. And they're moving around, flowing a little faster. Okay, so solids just sit there and do this. Liquids are kind of moving all free and flowing around. So we're going to draw it to the best of my ability. So I'm just going to kind of draw, there's a wave showing you that this is a liquid we're talking about. And again, you can draw actual circles. I'm just doing dots because my circles don't look so great. Okay, so these molecules, they're still kind of close together. Nobody's really touching. They're moving around. Okay, and then if you want to draw, let's change color here so you can see my flowing lines. If you want to draw some lines showing that they are flowing freely, well, that wasn't really a free-flowing wavy shape. They're just kind of moving. All right. That's the best you're going to get out of me for a liquid. Okay. We got one left, and that is gas. Let's erase our liquid picture here. There's got to be an easier way of doing this. There's got to be. Just don't know what it is. Ooh, I just thought of something. Okay. I think I might know an easier way of doing this, and I will try it with the gas. Okay. We'll see if it worked. All right, so our last state of matter is gas. Oh, I forgot I threw this joke in here. I crack myself up. Cats are liquids. They take the shape of the container while maintaining a constant volume. If you've ever seen a cat, they're a little weird, but like, see, he's taking the shape of this bowl that he's trying to cram himself into. I thought it was funny. All right. So a gas. Gases are weird. There is no fixed shape. And there's no volume. Gas is going to keep spreading out to fill whatever container we're talking about, whether it's the half of my water bottle or whether it's an entire room. For example, if you are baking cookies and you smell that delicious cookie smell, those are cookie gas molecules, basically. And eventually, those gas molecules are going to keep spreading out, and they're not just going to be in the kitchen. They're going to spread out to the living room, and maybe even somebody walking by on the street is going to go, I think somebody's making cookies. Because those gas molecules are going to keep spreading out. They have no shape, no volume. They're spaced super, super far apart, and they're going crazy. Sometimes they run into each other and bounce off and go the other way. But really, gas molecules, they're nuts. All right, so we've got solids, liquids, and gas. Let's draw it. Okay, I'm going to try something and see if this works to draw our gas molecules over here. Let's see. Don't know if it'll work. Oh my gosh, it did work. There's one gas molecule. They're all over the place. Oh my goodness, they're so spaced out. And I'm going to add little like zoomy tails to them here. Showing they're flying around. Oh my gosh, why didn't I think of this sooner? They're flying around. Still not the prettiest, but it is so much better than it was. All right, there's our gas molecules zooming all over the place, flying around. Once you have gotten to this point and you have drawn all three of our states of matter, you again are going to have us sign off on it before you move on. So pause it right now until you get that checkpoint signature. Oh my gosh, this is so much easier. And now we know. Beautiful. All right, so I have a music video for you to watch all about these three states of matter. Hit play and enjoy. I will be singing this song like for the rest of this unit, so you better pay close attention to it. Here you go. Oh no, I paused it. Start over. If you look at those molecules on their shirts, you got a solid, a liquid, and a gas. We'll make it full screen.
Want to learn about matter? Come and talk with us. Matter is everywhere, and stuff you can't see. There are three states, each with its own properties to tell. Between each one, solid, 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 liquid, 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 gas.
States of matter.
Solid, 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 solid,
liquid, 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 gas, 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 gas. States of matter.
This matter has
Fixed
a size and shape. Molecules are tight,
no room to shake,
but when you add
a little heat,
it starts to melt.
What can it be? Solid, 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 solid. States of matter. States of matter.
Solids keep melting, atoms start to move. When solids get more heat, atoms get more room. The new matter that forms has no definite shape.
It's got volume to measure, but what is its state? Liquid, 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 liquid. States of matter.
Liquid, 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 liquid. States of matter. Last when you add heat to liquids, they start to evaporate. Molecules go crazy, they have no definite shape. Atoms have more energy, bounce all over the place. They have no volume, they fill every little space. So put your hands up because there's matter everywhere.
Gas, 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 gas. States of matter. All right, so that is the States of Matter rap, and don't worry, I will be singing that quite often. So now we're going to talk about how you go from one state to another, and some of these, most of these, should be super familiar to you from your everyday life. Okay, so we call these things phase changes. Feel free to pause whenever you need to write down those definitions, but a phase change is just changing from one phase to another. Duh. Okay, and the way we do that is either by adding heat or taking heat away, making it colder. Okay, those are our two options, and that's what these arrows are showing you. Okay, so going that direction is adding heat. Going that direction is taking heat away, making it colder, which should make sense. If you look at like these two, you know those words. Okay. So the first one, oh, we're going to come back to that. I don't know why that's there. The first one we're going to talk about is melting. Right now, you know this word, obviously. Melting, we are going to be adding heat. Molecules are going to start moving faster and further apart, and you're going from a solid to a liquid. So the thing with this is, think about gym class. If you start moving faster, you start getting hot. Okay, so when you add heat, you're moving faster. And do you want to be like touching people when you're really hot and sweaty and gross? Not at all. So you're going to move further apart from people. Molecules do the same thing. So as we add that heat, those molecules are moving further and further away, and they're also speeding up. So we're going from a solid to a liquid. And think about this too. If I'm going crazier, I need to be further apart from people so I don't punch them in the face. So that's melting. Okay, and you've got the little ice cream cone cartoon right here, and it says, oh, quit your melting. It's only going to get us eaten faster. And ice cream's delicious. You've got a polar bear sitting on a melting piece of ice. That one is just sad. And you've got chocolate melting, which is still delicious, just a little messier. So that is melting. Now the opposite of melting, instead of going from a solid to a liquid, now I'm going to go from a liquid to a solid. This one should also be super familiar. It is freezing. In this case, I am removing heat. I am getting it colder. That's how a freezer works. A freezer is basically a heat vacuum. It's sucking all the heat out of that freezer. And molecules are going to slow down and get closer together. Think about this. If I put you outside at recess in the middle of winter, not that Mr. Erickson does that ever, okay, it's going to be cold. You're going to start shivering. You're not going to want to run around that much, and you're probably going to huddle with your friends. Think about penguins. They all huddle together to stay warm. So molecules are going to slow down and bunch closer together because I'm going from a liquid to a solid. And I've got my hipster ice cube. He was water before it got cool. I hope you laughed at that one because that's one of my favorite ones. All right, so melting, freezing, those two should have been super, super easy. Our next one is vaporization. Okay, in this particular case, I'm adding heat. So my molecules are moving even faster and getting even further apart. This time I'm going from a liquid to a gas. Okay, so even faster, even further apart because you're going crazier, so you're hotter and you still don't want to punch your molecule friends in the face. And there's two kinds of vaporization that you are already familiar with. We've got evaporation that happens right on the surface like a puddle. The surface of the puddle evaporates. And you've got boiling, okay, which is obviously happening throughout the liquid. That's how you get those bubbles. Those bubbles are water vapor gas. They've turned from a liquid into a gas, and they're going up to the surface and popping and releasing water vapor into the air. You let a pot of water boil enough, long enough, there's not going to be any water left in your pot. It will have all turned into gas at that point. You also have this joke right here that my head is covering up. It says, "R.I.P. boiled water. You will be mist." Because it's mist now, it's vapor. So funny. You should probably fake laugh anyway. All right, the opposite of vaporization is condensation. Now, again, I'm removing heat, so I'm getting colder. And because I'm getting colder, my molecules are slowing down and getting a little closer together. So I'm going from a gas to a liquid. We're still moving, just not quite as much and not as fast. So examples of this, you've got fog. Your school is up on top of a hill. You should be very familiar with fog. We get it a lot. Okay, it's how rain clouds form and then release the rain. Most popular one that you see is this Coke or soda. If you've got any kind of cold drink, all those water molecules on the outside that make it all, the outside of your cup or your bottle all wet, that's condensation. There was water molecules in the air. They hit that cold soda or drink and turned back into a liquid. You can't see it, but there's a puddle on my desk right now because I was drinking iced tea earlier. And that puddle on my desk was all the condensation on the outside of my cup. Okay, so that's condensation. So those are the four main phase changes, going from a solid to a liquid to a gas, and then back again, gas to liquid, liquid to solid. Okay, and that's that diagram right at the top of that page. You're going to have to know that diagram. Here's a little hint. You need to label that diagram on your test. So I would make sure you know it. Okay, there's two other types of phase changes. Whoops, let's go back to this here. And those are sublimation and deposition. So a sublimation starts as a solid, and I'm adding heat and going directly to a gas. I totally skipped over being a liquid. It doesn't happen very often, but dry ice is an example of that. I'm going straight from a solid to a gas. The opposite of that is deposition, going straight from a gas over to a solid. Okay, I skipped liquid altogether again. An example of that you see all the time is frost on leaves. Okay, so all that water vapor in the air, it gets cold at night and instantly freezes on leaves, and that is deposition. Okay, now you're going to do a little bit of practice. On that back table, you are going to find a page that looks like this. Okay, this is what you are going to do. Oh no, my directions are not on here. The directions are on the next page of your fact sheet, and you are going to color the 5 title boxes. So those are the ones that say starting state, ending state, or starting state, ending state, add, remove heat, example, and phase change. Okay, those 5, you are going to color those purple. Whole box colored in purple. There are 4 phase change boxes, and those boxes say melting, boiling / vaporization, freezing, and under there, condensing. You're going to color those green. There are 8 boxes that say your states of matter. That's anything that says a solid, liquid, or gas. Those, you're going to color all of them orange. There are 2 boxes that say you are adding heat. Those 2 right there. You are going to color those red heat. That should make sense. The 2 boxes that say remove heat, you are going to color those blue. Remove heat, cold, makes sense. And then all of your example pictures over here, there's 4 of them. Those 4 example pictures, you're just going to color in those pictures however you see fit. If you want a pink ice cream cone, go for it. Okay, you're coloring in those pictures how you want to. You are then going to cut out all of those squares. Every individual square, you're going to cut them out. And you're going to arrange the 5 purple title boxes across the top of the next page. Okay, so if you are on this page that has directions, if you turn the page, the title of that page says phase change cutouts page. Okay, you're going to arrange your 5 purple boxes in the order I gave you in the directions right across the top. Space them evenly across the top. You can glue those down right now. Okay. You are then going to place your 4 green phase change boxes, whatever order you want, underneath the phase change title box. So let me do a quick sketch here. I don't have purple, so just pretend. 2, 3, 4, 5. So at this point, you should have, I'm just going to write phase change. Then we have starting as, you have ending as, you have the heat one, just going to put an H for heat, and you've got the example box going straight across the top. Those are purple. I just don't have a purple pen to work with here. Your 4 green boxes, whatever order you want to do them in, put them right under this phase change. I'm out of room, but you get the point. Keep going. Now, if that first phase change you put was melting, well, then you are going to take your starting as box. And what does it start as when it's melting? Well, it starts as a solid. And these are orange. I don't have orange. This is the closest I have. So you are starting as a solid. You are ending as a liquid. Then you're going to pick one of your heat boxes. Is heat added or removed? Well, melting, heat is added. So I would put one of my red heat added boxes there. And then you're going to find your example. Which one of those pictures is an example of melting? It's an ice cream cone that is melting. That's the best I can do for a melting ice cream cone. Okay, so you're going to fill in all of those rows. You should have all 4 phase changes in green, and then decide how to fill in the rest. Before you glue any of those boxes down, place them on this sheet and call a teacher over to make sure they're in the right place. Because if you start gluing them down and we're like, melting is not going from a gas to a liquid, you're going to have to rip them off the sheet. So don't glue them down until we have checked them. Okay? So pause this video. Do your phase change cutout sheet. I should be paused right now as I erase. Don't mind me. Ignore that bell. Hopefully it's not the end of class yet and you have time left. So we've got a little bit more phase changes before you are at your next checkpoint. I wish this was like the smart board and I could erase it all at once, but I can't. Oh my goodness. Almost done. Almost done. Okay, got it. All right, so now you could unpause me. And we've got some more vocab that we need to do real quick. And here are these vocab words here, okay? So you've got boiling point, freezing point, melting point, and condensation point. Those are just the temperatures at which those things happen, okay? So the boiling point is the temperature at which a liquid turns into a gas. Now, the boiling point of water, we're using Celsius here because it's science. The boiling point of water is 100 degrees Celsius. Make sure you write that down. Boiling point of water is 100 degrees Celsius. The freezing point, that's the temperature that I freeze at. The temperature at which a liquid turns to a solid. And for water, the freezing point is 0 degrees Celsius. And here, let's just put these up in case we're not listening very well. Okay, so the boiling point of water is 100 degrees Celsius. The freezing point of water is 0 degrees Celsius. Now, here's our weird ones. Melting point. This is the temperature at which a solid goes back to being a liquid. That ice turns into liquid water. Here's the weird part. It is also 0 degrees Celsius, which means right at 0 degrees Celsius, I got a little bit of ice, I got a little bit of water. 1 degree warmer, it's all water. 1 degree colder, it's all ice. Which means then, using our brains, condensation point, when I turn back from a gas to a liquid, opposite of boiling, is also 100 degrees Celsius. So at 100 degrees Celsius, I got a little bit of gas, a little bit of liquid. 1 degree warmer, it's all gas. 1 degree colder, it's all liquid water. Okay, so those are my boiling, melting, freezing, and condensation points. Let's just get rid of that. Pause anytime you need to write stuff down. That's why these videos are so helpful. Okay, now we just have one more thing we got to do, and that's labeling a phase change diagram. Okay, so this is just a graph of all of those states of matter. Okay, so we've got 4 points that we need to label there, right up there. Melting point, freezing point, boiling point, condensation point. Now, how this works, follow my mouse here. I start off as a solid, okay? I've got temperature here. And I'm going to increase my temperature all the way up until I get to letter B. Now, when I get to letter B, something happens. I start melting, which means I should probably label letter B my melting point. Okay, I'm just going to write the initials because I'm not great at this pen yet. You write the whole thing. Okay, so my melting point is where that solid starts turning into a liquid. Now, this is the weird part. See how at my melting point, it stays the same temperature until I get to letter C? This is crazy, and we're going to do a lab to prove it to you. Okay, but all of that ice water is going to stay at 0 degrees Celsius until every single molecule has turned into liquid. Meaning, until it's all melted, it does not change temperature. Once every single molecule is liquid, so that's point C, then the temperature will start going up again until it reaches here. I've got a phase change that's about to happen. It says vaporization, which means that is my boiling point. Again, you'll notice this flat line here. Until all of the water has turned into gas, it's going to stay the same temperature. It's going to stay at 100 degrees Celsius. So no matter how much you boil a pot of water, it'll always be 100 degrees Celsius because there's still water in the pot. Until there's no water left and it's just gas, that temperature will never change. Once it's all gas, then the temperature goes back up. Now we're going to do this backwards. We're going to start at letter F and work our way back down. So if I start as a gas and I cool it off, eventually it's going to get to point E. This is where a phase change is going to happen, turning from a gas to a liquid, which means this is my condensation point. Again, we're going to stay at 100 degrees Celsius until every single molecule is a liquid. Once they're all liquid, then I'm going to get colder still until I hit letter C. That's my 0 degrees Celsius. And I'm going to start freezing, which means this is my freezing point. And I'm going to stay at 0 degrees Celsius until every single molecule is an ice cube. And then my ice cubes can get colder again. All right, so at this point, your graph should be labeled. Your phase change cutout page should be done. Everything in your fact sheet up to this point should be done. And this is where this video stops. You are going to get teacher initials at that checkpoint right there. And you're going to hit submit in Google Classroom so you get credit for finishing this video. I know this was a long one, but we're done with that first part.